start off, my transmitter circuit is powered with one 9-volt battery. I decided to split it to negative 4.5 volts and positive 4.5 volts to bias my op amps. To do this, I used a voltage divider with equal resistance to split the 9-volt battery evenly. It's important to choose a resistance value that's not too high and is not too low because you need an appropriate amount of current throughout the circuit. The buffer circuit creates a global ground for my transmitter circuit. Next, I have a simple mic circuit that was taken from Lab 4 Ideas. The mic is in series with 20k ohms to control the amount of current and protect the mic. I included a filter that consists of a 1 microfarad capacitor and a 20k ohm resistor to filter out any DC offset because I will feed this into a non-inverting amplifier and I want to amplify only the AC signal. The signal from the mic is fed into a non-inverting amplifier to, like I said, amplify the signal. Next, I feed the signal from the mic amplifier and the aux cord to a summing amp to combine those two signals. Lastly, I feed the signal from the summing amp into a bias T. This gives a DC offset that needs to be around 4.5s in order to power the laser because, as I mentioned before I had taken out any DC offset, but now I'm putting more back in. And that's pretty much the transmitter circuit I used. For my receiver circuit, I also powered it with one 9-volt battery and I also split it to negative 4.5 volts and positive 4.5 volts using a voltage divider. I used a buffer again to make a global ground for my receiver circuit. The reason I separately powered my transmitter and receiver circuit is because when they shared a ground, I was getting a lot of feedback and noise. This completely separates the two circuits and solved that problem. The photodiode, which is used to receive the signal from the laser, is input into an op amp into the negative terminal and positive terminal. Before feeding the signal that output from the first op amp, I used a capacitor and resistor to filter out any DC. I fed this into a non-inverting amplifier to amplify the signal. The resistor before the speaker is a potentiometer that I use to adjust the volume, and that's pretty much my receiving circuit.
My transmitter took two inputs, a microphone input and an audio source input that could be plugged into a phone or a laptop. The microphone circuit was taken from lab ideas given to us in one of the labs, and it was put through a high-pass filter and a mic amplifier. The amplifier was a non-inverting amplifier, and the negative feedback loop had a potentiometer so that the microphone signal could be adjusted. The audio source was also put through a high-pass filter, and there was a potentiometer placed before it so that the audio source could be adjusted. Both signals were sent into a summing amplifier, which put the two signals together, and then they went through a buffer to make the summing amplifier independent from the rest of the transmitter. The transmitter used a bias T, where the audio signal went through a capacitor and a positive 4.5 DC voltage went through an inductor, and both were fed into the laser, where the negative end was powered by negative 4.5 volts and the positive end had the output of bias T. A buffer was also used at both ends of the bias T so that they were independent from the rest of the circuit. My receiver used a photodiode where the negative end went to ground and the positive end went through a high-pass filter. That signal was then sent through 3 parallel amplifiers that were non-inverting amplifiers, where one of the op amps had a potentiometer as the negative feedback loop so that it could be adjusted. That signal then went to the positive end of our speaker where the negative end went to ground.